So, welcome to this course in Agile Engineering, and sorry for the delay. Technology has a way with you sometimes, and it did this time. I will start off this course by letting you know what you're supposed to do, and then I will hand things over to Tobias, which will be talking about Scrum and some other stuff here. So, first of all, I am not an employee of LNU. I am from the other side, and the other side is the business sector. So I've been working with this for some years now, since 1991. I've been doing a few things like programming, and I've been in software engineering and project management and all of those things. But in this course, you will meet me in having two roles. The first one is as a product owner for a project, which I will be talking about in a few minutes. And it's not a real project in the sense, but it's a project that we want you to help us out with just for the course of this course. And the other role I will have is as a mentor. So if you are having a kind of a trouble or something like that, you will be talking to me and I'll try to help you out, because we will have Scrum Masters in this project. So the project itself is this. So you can have a look at the bottom item first there. There is a save the planet thinking behind this. So this is my idea. So let's assume that you have been talking to a few local producers and they need to get more competitive. So what they have been doing is trying to just join forces and try to figure out a way of selling things and make the world be a little bit better. So what they are trying to do here is to create, or at least describe, a system for you that is going to sell or auctioning locally produced goods. And that could be like potatoes or milk or just about anything. The thing is that they are locally produced here. And what they have been doing so far is that they have had a prototype created. And that prototype was kind of a success. So they decided to, well, let's take this to another stage and try to create a real product of it. So they have raised a few dollars or Swedish kronor, which is kind of a funding, and they will try to create a pilot project, a sort of a minor product, and they will try it out on some local consumers. And that will be in the area of Växjö, sorry for you Kalmar guys here. So within a 50-kilometer radius, they will try to hook on to new customers. So this is what I'm going to tell you right now. I will give you quite a lot of user stories later on, but this is what I'm going to just give you a hint on what this is supposed to be doing, this system. So if you view me as a product owner, this is what we need help with. And what we expect you to do is to lead this endeavor. You're supposed to lead this endeavor. And you are most welcome to suggest things, because as a product owner, I know what I want, but it might not always be the right thing to do. And you might come up with some absolutely brilliant ideas. And if you do, just suggest things to me. And another thing, we are not very good at managing or handling computers. So what we can do is that we can log on to our computer, let's say it's a Windows system or a Mac or something, We are very good at starting the browser, but after that, it all stops. So if you tell me to open a certain program, you will most likely need to help me do that. So I am not very good at handling a computer. So don't expect me to be a programmer when I am the product owner. And this is quite a problem which I'm talking about right now, because if you are assuming too many things here, you will kind of fail, because you will be running in the wrong direction. And if this is what I'm going, that's the short story. That's what I've been telling you right now. So if we are going to move over to some other stuff here, and that is more of like I'm hinting to you here, do this, and I think you will start off quite well here. And the first thing is talking about solving problems. And that's the first one. You need to understand the customer's situation or the state of him or her. If you don't do that, you will never succeed. What you will get is a very angry customer, and you don't want that. An angry customer is a bad customer. And I know that because I've been doing this once or twice. I have a few stories if you want to hear them later on. I need to switch over to Swedish because there are quite a lot of swearing words in that stories, or in those stories. And the next thing here is that you are supposed to add value to your customer. You never solve things, because when you're solving things, you act like a robot. So it's a lot better if you have this attitude instead. I'm going to add value to you. Because when you're adding value, you're giving things to your customer, and that organization or company will be a very happy one. And adding value can be a lot of things. I mean, if you're adding value by going for a coffee break with your customer, then you're adding value. Or you're just holding their hands, you're adding value. But if you're talking about high-tech stuff, then you're probably not adding value. Not in this situation we're having here right now. So add value, that's a good attitude. And the other thing here, and there are quite a few times when I've been noticing this, that if you are sort of leaning towards a process or a method, you might think that, okay, we're home, we're done. We have this Scrum or the old-fashioned waterfall method. If we just use those methods, we're okay. But that's not the case. That's just a guideline for you. You're supposed to think. And your process or your method is just a guide for you. If you don't know where you are, you might read into that guide and sort of understand your own state in this endeavor that you're on. All right? So never lose track of your own state in things. And okay, so we've been talking about adding value. We have been talking about things like you're supposed to think. Let's move over to this, because I think that this is a generic solution. What you have here is a few components or objects, depending on whether you know UML or not. So I think that this is what you are thinking of right now. In the middle, you have your web server. And on your left-hand side, you have your database management system containing a database. And to the far right, you have your clients, which might be a browser inside an Android phone or a Windows 10 machine. No Macintoshes here. Sorry for that. So I think that you're landing somewhere in this, somewhere like this. Whether you're using a standard SQL database or a NoSQL one, that's up to you. You might use any kind of technology you feel like in this course. You may select any programming language you feel like as well. I do not care. That's your problem. I just want to have my system delivered from you at the end of this course. But if you want to have a talk about it, then you just give me a call. So that's my technical overview. That's just a hint for you, but you do whatever you feel like. So, okay, we have our customer, we have our technical overview, and the next thing here is just a few thoughts on how you do create stuff in your own private life. And if you have this problem where you have a start somewhere, this is your start over here, and you're supposed to create something or do something, you're on a mission, then you also have a goal, because without a goal you don't know when you're done. So I think that this is the general thought. Okay, I have my goal somewhere and that's what I am aiming for. So if you're building a house, for instance, then you know where you're heading. But the problem is that when you start your building, you never know where you're supposed to end. So your true goal is somewhere else. And that red line has a title on it. It says expensive. And that line and that expense can be awfully high. It can be in the size of you're ruining your own company if you're unlucky. So if that thing here, you sort of thought that, okay, it will probably take me 1 year to do that or create that or build that house. What it might end up with is that it takes another 3 years. So if that was expensive in your mind, then that part might ruin you. So this is obviously a bad idea for larger projects to do that. So what you try to do is that you do it like that. Oh, sorry. That's another part. If you're creating a house or building a house for your customer, they usually never understand what they want. So take that with you. So this is what you are supposed to do, most likely. You are building a few things, having a deadline or a check-off with your customer, build a bit more, check out, build a bit more, and at the end you are at your true goal. And I think that that's what you actually do when you're solving things right now. But you never think of it. And that's quite strange when you come over to the software business, because sometimes they just go for it. So it's a lot easier to take small baby steps, even if it feels like you're wasting your time. But it's the other way around. So, but there's this is not a promotion of anything, but there's a thing called CEMAT, which you might want to have a look into. If we have enough time, I can talk about it, but it's a good way of getting, or at least finding, the state of things. Let's assume that you have an opportunity. You have found an opportunity. Then you need to understand in what state that opportunity is, because if you think it's an opportunity and it's not, then it was a bad idea. And it always is like that when it comes to your stakeholders. If you don't have any, then you have just an idea. So this is something that I use occasionally, because it's quite hard to implement this on some segments of the industry, because they are a bit old-fashioned and they don't want to hear the truth. But have a look at it and you kind of, I think, will find it very usable. But this CEMAT is not a part of the course anyway, but I'm just promoting things here. Sorry for that. So, what I want you to do is to start thinking. You're allowed to think. Okay, so that was a bit about the project and a few friendly words from me to you. Let's move over to the course itself. It will be based on that project, and I will divide you into teams. And the size of the teams is somewhere between, or at least say 6 to 8 persons. And since I don't know, I have no idea what you have with you in your technical luggage or baggage, I need to ask you. So if you go and have a look at the course page, you will find a link to a cross-function form. And it has a few questions such as, do you know how to manage a database? Are you any good at graphical user interfaces and so on? And there's a grade here. If you think that you're really bad at database management systems, then you're grading yourself at 1. If you think you're a real master, you grade yourself as a 5. So this is what you think of yourself. But it sort of gives me a feel for if you think you're good or bad at something. So I try to evenly divide you into manageable teams here. So you will be equally good. So that's the easiest way to do things here. And I want you to complete that form before 8 o'clock on Wednesday. So that's just a way for me to creating teams. And then we stumble upon peer reviewing because there is no exam per se here. So when it comes to grading, we're going to use peer reviewing, which means that within a team, assume you're part of team A, then you're supposed to peer review your members, not yourself, but your members. And you're supposed to, let's say that you're given $20. And what I want you to do is to distribute those $20 among your team members. So if you think that one of your members is really, really good, you can assign that person $10. And you might think that some other is quite good, but not as good as the first one, so you assign that person $5 and so on. Which means that you might think that there are some fellow members here that are really, really bad, then they will not be given any dollars at all. That might seem to be a harsh thing to do, but that's life. And mind you, if you try to cheat on us, we will notice that. There are patterns to this. So, because there are a few persons that might say, "Sir, okay, if I give you $10, I will give you $10, and you will give me $10 and all that stuff." But there's a pattern to it, and we will find it out. So, just a bit of warning here. You will be peer reviewing on 2 things here. First is the technical aspect. Do you think that your fellow members are good at implementing things? And the other one is, how good are you at following Scrum? So you are supposed to distribute $20 on the technical aspect and $20 on the Scrum aspect. And because you are doing this on a per week basis, so Tobias and I will have a look at it each week, and if we can sort of see that, okay, this member here is having some troubles. Him or her is given very low dollar grades here. We will have a talk to that person, and if we need to do that on 2 occasions, that person is disqualified from the course. Which means that The peer reviewing is the base for your final grades of this course. If you have any questions regarding this or just about anything when it comes to this course, just give me a call on Slack, or if you want to email me or phone me, just do so. No problems. We'll have a talk about that. And so a few other things here before I'll hand things over to Tobias here, and that is GitLab. When I'm acting as a product owner, I will add user stories, and I will add them to GitLab, and you will have your own area, one area per team, and each team will have a few stories added to it. And I usually add the same thing at the beginning. Depending on how well it goes, or because this is a course on agile engineering, not software development or programming. So some teams might be a little bit better than other teams. And depending on that, the better teams might be handed over a bit more user stories. So just relax if you have a feeling that if you select Java as your programming language, I might be not that good at Java. Just to relax. We figure that's not a problem. Each week will also contain a sprint review and a sprint planning. And the sprint review is for you as a team to show me as a product owner what you've been doing the last week. And we will have a discussion about that, and I will probably have a few suggestions on new user stories that I want to be implemented into the next iteration. The original plan for this was each Friday, but I have to get back on that because I have a possible clash here. And I also need to know how many teams there will be in this course anyway, so let me get back on that. Right. That was fast. But anyways, if you have any questions, just put them on Slack or email me and I'll answer it. I promise you. Okay. Tobias.
Yeah. Just a second while we change computers. And image, please. All right. Now you see me. Both me's. Presumably. Oops. And I'll start the presentation. And no more gorilla. All right. Hi, welcome again. My name is Tobias, and I will be the LNU employed for this course. So I will be part of this. You will probably meet Lars quite a lot more, but I will be here in the background. I will be looking into Slack. I will be at the end presentations. I will try to help out with GitLab and stuff like that. So first off, short presentation of me. Some of you I've already met, some of you I haven't. For all of you, I could say that I've been a teacher at LNU for a long time. However, I also have a distant past by this time in industry. I've been working as a consultant at an IT firm in Växjö for a few years. And hopefully some of that can trickle back into this as well. And if there are any questions you have about the course itself, You can also mail me or look me up on Slack. I will be available there as well. I'd like to, most of you, or if not all of you who are watching this right now when we're going live, will have found the Slack channel, but if you haven't, please tell everyone that that's our main way of communicating. All right. Next off, some of you might recognize me also from a previous course, which is fairly similar to this one, 1DV508, project in computer science. And that's true. These two courses are quite similar. However, the idea and the focus of this is to take it up a notch. In that course, we try to give you a lot more of what you were supposed to be doing, while in this course we are going to work more with Lars as actually being a customer, and also giving the opportunity for you to set a number of rules for yourselves, like, for example, programming language or technologies you'd like to work with, which wasn't the case in that previous course. So this is really quite a good step up from that previous course. That said, a lot of the things that you will find me saying today, and a lot of the things that we will be working with, for example, GitLab and so on, will be more or less the same. So no changes there. So what I'm going to do today is to give you a brief presentation on projects as such, and with can change here, with Scrum specifically. And this is also something that I have been working with during my years as a consultant in the IT industry at a company in Växjö. I was actually in charge of trying to, and I say try to, get everyone onto Scrum. That was a bit early for some of the colleagues, so well, I tried to. I did my best, and then I went back to academia. So hopefully it will be a lot easier to do that nowadays. So I will go through all of the normal things, talk a little bit about projects as such, moving over to Scrum, and look at the roles and ceremonies and artifacts that you will find over there, and end it all with GitLab. So just a few slides telling you how we are going to use GitLab as part of this project. There are, you can probably not see because it's somewhere down there, but I have 74 slides. There's no way we're going to do that before lunch, so we are going to have lunch breaks, or one lunch break, and then I will continue after that as well. And we'll continue until we are done. All right, let's move on with general projects. So what we are going to talk about is projects on a higher level. Most of you have probably worked quite a lot with the specifics in a software development project by going headfirst into developing. However, when creating a project, you also need to take one step back or up and look at the things that surrounds the project, that makes this a whole, and which leads us then into the specifics. So a project as such is a temporary endeavor to accomplish a unique product, service, or any other kind of result, as it says here, meaning that it is kind of a one-off when it comes to us. We are going to, in this case, create presumably a web page, but we don't know, for selling these local produce. But this is not something that we are going to do in a number of times exactly the same thing. So a project has a goal, it has a time frame, it has resources, ownership, budget, and probably also an executive sponsor, someone who wants this. So just as Lars said, we need to have a goal. The goal might not be what we end up with all the times, but we will try to find ways to find the goal that we really want to achieve. But the important thing is to have a goal, something to look at, to see and understand that this is what we want to find out or come to. It has a time frame, and in this course you will have a number of weeks in which to do this. In real life you might have months or possibly years to do it, but the important thing is that it's not like we start over here and will be done when we're done. So it has a time frame. It has resources, meaning that this is what we are going to build this project with, and that's everything from computer power to the people actually doing the stuff. And all of these will also have time frames and goals of their own in hopefully this project, but possibly in others as well, meaning that we need to keep things tight. Ownership, just as it says, someone who actually owns this, who is willing to stand up and take responsibility for it. Budget, again, money, yes, but also all the other resources are limited for most projects. And the executive sponsor is someone who can chip in with all of this. So with that, we can say that a project is goal-oriented. It has a specific end result and consists of a number of activities to be executed within a limited time with limited resources and budget. So that is a project on a high level. That's what we start off with. It doesn't say anything on how we actually set about to do the different things, but it does give us the frame of how things work on a high level. So the specifics can be done in many different ways, but a project is this. So if we look at the different parts, we can say that, as I said previously, it's goal-oriented, and that's a goal, meaning that we need to have something pretty well defined that we point our eyes to, and that we know is what we at least intend to achieve. If we cannot do that, if we cannot find ourselves with an image of the end result, then maybe this project should be abandoned at an early stage. And this, however simple it seems, is not that uncommon of a problem. That we have a vague idea of what we want, but we need to be a bit more goal-oriented than that. And sometimes, if we look at it, it might be more than one project. So then split it up into smaller projects. And remember that requirements analysis and so on are important parts of actually finding out what it is we want. If we have a vague idea, maybe we should put a bit more effort in actually trying to find out the requirements of this, and then we can paint a better picture of what this actually is, and thereby getting our goal. We have a number of activities, and these range from everything from sub-projects within the project itself, working with databases, login systems, and so on, to on a higher level with all the different meetings or non-meetings that we need to have in order to complete our project. Meetings with customers, finding out the requirements, all of these are activities that we need to think of and we need to understand. Some activities are quite isolated. We do them and they do not depend on anything else. And these are fairly easy then to recognize. But there are also a number of activities that are not as isolated, but rather dependent on other things in the project. And that means that we need to find out a specific path of doing things. Limited time, so everything needs to have a deadline. And also, and this is equally important, we need to have a start date. And everything needs to be done within the start and end date of this project. This will, of course, not always work, but we need to have the deadlines to have something to work towards. And this is important because most organizations need to start working on another project after this first one, or whatever it might be. So they need to continue working, and the staff employed by the organization will get new projects, new things to do, and we need to be able to plan ahead and therefore stay within the allocated time for this project. Limited resources and also a budget, meaning again that we have persons, equipment and premises and whatever it might be that we need to use, and this is the only thing we have the possibility to use. And this is sometimes up to us, sometimes most of this is handed down to us, so we are given a budget with both the resources and the money in order to do whatever we're going to do. Could be that we need a computer for a limited time in order to create this, or whatever it might be. It's handed down to us, and therefore we need to be able to reason around all of these resources. Most projects are expected to keep within the budget, but unfortunately this is not always the case. So that's a project, and to manage something like this is project management. So basically this is the discipline of achieving the project goals while adhering to the constraints. So keeping on top of things, more or less. So the project management means that we establish clear and achievable goals, so that we paint the goal image, what we expect to arrive at, to plan, organize, securing and managing resources. So project management is often part of this group of people that actually handles the budget and the resources. Many of us will work down there on the floor, and we will be a resource sitting there coding or designing or whatever we might be doing. But the project management is about managing these resources. Balancing demands of scope, quality, time and cost, and of course communicating. And the last part, all the challenges. So in any project, anywhere, any kind, there will be problems with specifically human beings. They can be interesting. Most of you have already worked in smaller projects with other students or likewise, and you know that not all students go into a project with the same enthusiasm. So therefore we have different personalities. We can see some of them as highly functional and some not as functional. You also probably met the 10x developer who is capable really to do all of this much quicker than anyone else, but he or she is also extremely arrogant and difficult to work with, and so on and so forth. So one of the parts of the project manager is to work with these human beings inside of the group, but also outside of the group. The client, the one we are creating this software for, could also be fairly problematic. And I myself was involved as an IT consultant with one specific project, it's a long-lived project, where we had a client who didn't realize how important this was. So the spokesperson from that company, the one that they wanted us to talk with, he was an idiot. So I'm not going to say the company's name or anything like that, but this person was really difficult to work with. And it's then up to the project manager or the management team or whatever it might be to try to find out a way to actually communicate with a person like this. And of course, especially in that kind of situation, we had changing and incomplete requirements on anything we did. And that might be the case here as well. As Lars pointed out, he could be changing or give you a little bit different instructions depending on what he feels like he gets from you. And that's part of real life. If we have a look at the traditional project life cycle, we have initiation, planning, execution and control, and then completion. And this is again on a high level. So as someone working in a project, we start with initiating the project itself, meaning that we need to find out that this is what we're going to do. We need to find out a achievable goal, to have this goal image before us. After that comes the planning, where we plan out the deadlines, the start and the end of the project, what kind of resources, what kind of basic high-level requirements we have. And then comes the part where we will probably spend most of the time, namely execution and control. So that's where we actually perform what we are going to do. In our case, this is where the software development process will be. And then we have completion, where we try to get everything together to make it as a functional whole. Okay, so this is on a high level, meaning that for basically any kind of project, if you are building a house, you do something like this as well. You initiate, you want to find out if there is suitable land possible to buy. You need to know that there are suppliers of all the stuff that you need in order to build this house according to the grand vision that you have of this project. And when you find out that it might be possible actually to do this, to create, for example, a great new mall or whatever it might be. And when you have this initialization, you go over to the planning phase, where you try to find out if you can actually get this within this time frame. Is it possible for us to open this new mall within this time frame, and so on. And when you get all of this together with the resources and the budget and so on, you start building the mall, which is execution and control. And hopefully it will end up being a complete building with all the stuff that you want inside. But what we are going to do now is to step a little bit more into this execution and control, because most of us will not build a house. We will build some sort of software artifact later on. And therefore we are interested in seeing the software development life cycle, which, just as I said, takes part of the execution and control phase of the traditional project life cycle, where no matter what kind of project we do, we most often do these, and you've seen these before, I presume, phases where we have planning or requirements and so on. And we have some sort of analysis where we specify these requirements. And we have some sort of design where we create the basis of what we're going to do, or rather how we are going to do, and previously it was what we are going to do. And then an implementation and testing phase where we actually code the stuff, and if everything works out nicely, all of these will be helping us so that the implementation is merely to implement what we want, and later on maintenance and support, of course, sorry, as part of the normal life cycle. And as most of you probably know, these phases have been put in different order, well, not order perhaps, but in different ways, in different kind of cool and interesting ways of actually performing this. But these phases are the ones that we usually see. And while IT projects began there, it is evident that just making it like waterfall, if you like we saw in the previous slide, is not perhaps the way to do it. So these are old statistics, but they kind of work these days as well, saying that the average IT project costs twice as much as budgeted, which could potentially be quite a lot of money, and it takes twice as long as planned. And we've read this countless of times. Here in Sweden we have the Swedish system for the police for communicating, which has been delayed and redone and so on several times by now. You can probably find hundreds of projects that have gone overboard and not being what was intended, taking twice as long or more. It says it has 65% of the required functionality at completion, and yeah, I know just recently we having kids in school, they have different systems for communicating to parents, and I can tell you some of them are really bad. I don't think they manage 65% of the required functionality in these systems. So this is still happening. This is still a problem. 62% fail to meet schedule, 50% have higher than expected maintenance costs. This is bad. 41 fail to deliver the expected business value, which is perhaps the most problematic part. Just as I said with the systems in some of the schools where we have kids, they really don't make life any easier for us as parents or for the teachers who are going to work with these systems. It makes problem even more evident. So IT projects, for some reason, have been allowed to be like this. If we built houses like this, there would be so much noise about this. So you wouldn't believe it. If we did anything like this, there would be an uproar and revolution. But IT fails. And why does these projects fail? Why do they fail? Well, incomplete requirements is seen as the number one, and that's not something that's difficult to understand, because most of the systems we are going to use have a vision, a goal that is kind of vague. The people that want these systems, they want a system which makes it easier to handle kids in school, to have communication among the police better working, and so on. But they haven't really looked at the real requirements needed in order to do this. We have a lack of user involvement. in the beginning of time, computer programs were created by men, unfortunately men in white clothing, looking like lab technicians, doing all the coding, knowing a lot of mathematics and so on. They created these programs that were meant to be used by other people in lab coats with equally much knowledge of everything and so on. However, since the 90s, this has changed because there's user involvement, the real users, people like you and me, using these applications. And when we have a lack of user involvement in developing these applications, it ends up being very, very bad. Lack of resources, that's the normal one that you hear. Well, we didn't have enough money or people to do this. Goes hand in hand with the executive support sometimes. But, I mean, sometimes the lack of all of this is just because you haven't really understood the requirements. And that goes with the rest of them. Changing requirements on an unrealistic schedule, poor communication and so on. All of this goes hand in hand. And there have been quite a number of tries to get around this, to find ways to actually counter all of these specific things. And with Agile, as we're going to see later on, we believe right now at least that that's the best bet at actually getting to this, because it tries to address almost all of these issues. So the traditional methodologies before Agile had a number of clear problems, and this is way back then, so this is kind of waterfall territory. So it assumes a predictable world, so that this works when you're a man in a lab coat doing the coding. You know exactly how the world around you behaves. You are calculating the trajectory of a missile or something like that. There are very few unknowns. It might be unknowns when it comes to calculating the trajectory, but how everything concerning IT works is well known. And the competitive landscape didn't change in those days either. I mean, sure, the other guys could also try to do the same thing, to create a program to calculate the trajectory of missiles that they are going to send to you, but they are not going to sell that to you, so they are not a competitive business in that kind. And stakeholders don't change their minds. Again, in a predictable world, this is not a problem, because what that says is that we know what we want. And as it says on the last line here, it works fine for some types of projects. Sure, if you're going to send a rocket to Mars, you try to really think through everything before you send the rocket to Mars, right? So you don't have the possibility to halfway to Mars say, well, this kind of engine didn't really work, so we'll need to replace that with something else. You cannot do that. So you need to find out everything in advance. And again, that works. If you want to send something to Mars, you need to do that, and you can sit down with a lot of intelligent people finding this out. However, the majority of software today is used by people who are just that, people, ordinary people who as Lars said, might be able to fire up a web browser, but he doesn't know, or she doesn't know the exact pathway to the desktop metaphor on most computers today. Doesn't know a environmental variable. There are loads of things that a normal user doesn't know, and can therefore not say to you when creating the requirements. Yeah, and also availability of resources that doesn't change and so on. Well, I think we're on to that as well. So the first step was to try these iterative methodologies. And the motivation behind these was that requirements do change. So iterative means that we do it again and again and again. So requirements change and the world around us changes, and we want to embrace this change. So change will happen is the idea. Whereas the traditional methodologies was a lot more minimize the impact of the change. But iterative, well, we know that things will happen, so we will need to adjust to that. And that was a good idea. That worked nicely for a while, at least. It made things better. So we get something like this instead of just doof, 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 we have so it goes around in iterations instead. So we do initial planning, we do requirements, analysis, design, implementation, testing, evaluation, all of this again and again and again. And we can see that this is something you probably looked at agile development before in one way or another, and you'll see that this is part of the core of that as well. But as far as this went, this was all of it in iterative methodologies, namely that you did these parts. You did the planning, analysis, and design and so on again and again and again till you got, to deployment, and you were done. So that not always that much of user involvement, for example, and you did all of it all the time like this. Therefore, someone was thinking about doing it incrementally instead, and incrementally means that we do one piece of it instead, because instead of like we do in iterative development, where we start working on the project and builds it up as a whole, we in incremental methodologies rather take the parts and build this part, a chunk with a business value, and we create another chunk with a business value, and then another chunk with a business value. And again, requirements do change, and they say that partial functionality is valuable, and we embrace change. All of this, again, is something that we see in Agile, and we've seen in previous, and many of the incremental methodologies embraced iterative methods as well. So we get all of it. And it looks something like this, nice little image of where we've tried to define all the functionality like this, and we have different parts of it, and some of them are started, some are not, but all of these will have some sort of business value. So if we create a UI, we have something to show for the customer. If we create the middleware, well, if we can connect that to the UI, so to say, then we have something which might just be populated with mock values and so on, but something with a business value, and then create a backend and so on and so forth. All of this leads to Agile, which basically means that we push everything together to make it as a whole instead. Meaning that we take both the iterative and the incremental parts and put it into something, just as it says over here. Meaning that we will have an idea where all of these little chunks, all these increments are important. They need to have a business value, but we do all of these in an iterative fashion, which has a larger iterative process, which in the end will produce the final products. But you see that the different parts are still the same. What we've added also is the guy over there, which is actually someone to talk to from the client side. So Agile is incremental and iterative in this fashion. And if we've looked at, for example, the UP, Unified Processes, the Rational Unified Process and so on, they tend to be something similar, but not quite in the extreme that this was when it first came out. The UP processes, for example, they have this mindset. However, they work with mostly analysis in the beginning, and then shifting over to mostly design and mostly implementation. And when you get to the testing phase, there should be very little of the analysis phase being done at that time. So the idea here is to actually basically see a project as a number of sub-projects with business values and hand them out. When talking Agile, you really need to mention the Agile Manifesto, which was one of the things they brought to the table. So they put this on the table. They basically sat down, thought over what's important here, and what is it that makes a project really successful, and they just wrote it down in order for us to understand the basic idea of it. It doesn't say anything about the way we are going to work later on, but it sets the mind at the right things. So what we're going to say is that the Agile way of working, they think higher of the things in bold here and less of the things on the other side of over. But that doesn't mean that the other things are unimportant, but it does mean that we have a focus on the bold ones. So first off, the individuals and interactions over processes and tools. Agile doesn't imply any specific process or tool as such. Then we've created processes and we've created tools as well to help work in an agile fashion. For example, Scrum, as we'll talk later on. But the important thing is to have individuals and have these individuals talk to each other. And what they really mean with the processes and tools also that they want to see less of is that we don't want endless meetings. We want to have individuals doing this, and we want to have interaction between all the individuals so that we can understand change and do something when the change happens. Working software over comprehensive documentation. And I've seen working in a company before they started to embrace the more agile way of doing things, a lot of documentation. And documentation about the project itself, it's just as it says in the third one, with customer collaboration over contract negotiation. We don't need all of that paperwork for both the documentation and for the contracts. Try to minimize that as much as possible. So focus on creating software that does work instead of using countless hours on documenting the things you need to do. This doesn't mean that you don't have to document your software. That's important too. But you need to document it in a clever way, in a smart fashion, to, for example, see to that your software is easily testable, to have loads of good comments in the code, and so on. And also, of course, on the usage of the software. Customer collaboration is highly valued in any agile approach, meaning that we need to talk to the customer rather than have a meeting with the customer in the beginning and deliver a product in the end. And this is really, really difficult. Where I worked, this was perhaps the most difficult thing, because my managers, the people at the IT company, they wanted to say that we are going to deliver this at this price at this time, hand it over. And the people on the business side, they wanted to receive this kind of paper saying, we are going to expect to get this for this price at this time. And then when either part couldn't fulfill this, there was loads of negotiation. If the customer wanted another piece of functionality, negotiation. If we couldn't deliver the software functionality in time, negotiation. And somehow top management seemed to really enjoy this. That's kind of their life, it seemed like. So getting all parts to understand that we should try to respond to change over following a plan was really difficult. They wanted black on white, this is going to happen, and if it doesn't happen, there will be consequences. Whereas it's shown later on, not at the time when I try to introduce this, showed again and again that it's much better to just try to find out what we want and build that. It will become cheaper. It will be done faster. It will not be done that way, but it will be the end result that we are aiming for. And these guidelines, when followed as they are intended, will give you a better project. Some developers mainly use these things against each other, so to say, in order to kind of cheat in projects, to don't have any documentation, to not having any kind of plan, and don't caring that much, and so on, and making software that's just not, well, it tends to be that you try to create your software and it evolves into what you want it, and then you don't follow that up with proper documentation and so on. So you still need that documentation, but some say, well, we'll take it easy, and so on. So agile software development, as opposed to the more traditional ones, relies on empirical data from short feedback loops, which is the important part here, to involve the customer, the client, the one who actually wants this. So continuous deployment with customer feedback. We create increments of things with a business value that the customer looks at and says that this is good or this is not good. continuous integration with tests and builds, and thereby quality feedback as well. So when we create things, we see to that it's easily testable, and we try to create it so that we get this feedback all the time. And since everything is continuous, we also respond quickly when things go the other way. So we will fairly soon find out that something isn't working, or it isn't what the customer expected, and so on. And we can embrace that change and actually do something against it, or for it, rather. So we're going to talk more about sprints later on, but the idea here is that we have increments of value so that we have something to show the customer in one way or another. And there's been a number of different agile methodologies, because agile is this way of looking, and as I said, we value tools and processes less. However, by creating agile methods, we find ways to make this all easier. And there's been quite a lot of different ways of doing this, and we can see that this, again, fairly old numbers, but I suspect that there are something similar still, with in this case 56% being Scrum, and hybrid being fairly large, because that's just as we have 1% Spotify model over there. There are also a number of different tweaks to Scrum or other agile approaches that have been in use in different companies, like Combitech, for example, and Visma, I know, are as well having their own, or at least had their own way of doing it. But we can see that Scrum is something that most companies tend to use, and therefore that will be the basis of what we will actually do in this course. We can see at the top we have this 1% extreme programming, which in the beginning was actually one of the most used agile methodologies. Extreme programming being when you work in pairs and you help each other in a fairly tight situation. And that was very, very common in, say, beginning 2000 and so on. But perhaps not as streamlined for larger projects than Scrum is, which is something that we are going to look further into. So basically, all of this agile is what we call a disruptive social technology, meaning that it is so different. Nowadays, it feels kind of natural to do software development in this way. But just as I said previously, with this higher management, it's fundamentally different from how they tend to and want to and used to do business. It's a little bit like if you ask a carpenter to do something and in your house, and he wants to say, let's see what this costs, and he just works. You don't want that, because you tend to believe that the carpenter then will drag on indefinitely and so on. And that's not really the idea of agile either. It's one of the things that you can point in its disfavor, that a lot of people think that you just work ahead with no plan to begin with, but you do need a plan, and you do need some sort of at least tentative deadline for this project, because again, you are going to use the resources in the form of staff, for example, for other projects later on. You will need to be able to plan ahead a little bit. But when it comes to a single project, it's not that planned and that specified to begin with, as we don't want that. We want it to be something that more or less evolves then. So this transformation into this new way of thinking isn't easy, and I can tell you, as I did previously, that trying to get this into the company where I worked was extremely difficult, because it was kind of the opposite of how they usually worked. So they want to use this, but this is how it's always been done. They want to say that let's do it like this because we've done it like this since the dawn of dinosaurs, basically. But it is another way where this senior level authority is muted, and that might be one of the problems. The senior level, so the management, the upper management, isn't that important in agile development. In agile development, the team will work in order to get to this goal, but we don't want the senior level managers to say that do this, do this, do this, do this, and we have this deadline, and so on. We want it more organic. And that means that upper management isn't as important, and they will turn really, really angry because of this. And all the other things, the toxic assumptions, antithesis of traditional project management. Just as I said, it's always the other way around from what we've used to do it, and that takes a lot of time. And it's important to remember that it does take a lot of time also for the people inside of the project. So I go on and on and on and say that upper management is crap and so on, but it's likewise difficult for the people inside of the project. We still have deadlines and so on as we work in sprints, as we'll see later on, but the problem is that it is still another way of thinking. And I worked with other project managers at the time inside of projects. Our project manager inside of our project that felt very uncomfortable with doing things this way instead of doing it the way that they always done it. So that's agile on a whole, and if we move on, we will have a look at Scrum more specifically. And my idea is actually that we break for lunch here and continue again at 1. Could we say that we meet again at 13 sharp? And I seem to have lost some network access actually, so let's see if anything else works. No connection. Last updated to. Please connect. All right. Since this will be recorded, hopefully it won't be a problem. But I will start again at 13 sharp, and everyone is welcome to listen. And if you don't want to listen, we'll put it up on the Moodle page as well. So see you later, or not. See ya.